I'm still very much preparing. I'm late. But we'll get there, we'll get there. We'll leave the music going for a little bit. Let's put some stuff on the background. I like Pacific. I can't really see it right now. There. Good evening! How are you all doing tonight? I'm still gonna be preparing during the pre-stream because I didn't get to do that before the pre-stream, whenever that was. We need the thermal camera today, so we're gonna see if we can hook it up. Yeah, it's music by Approaching Nirvana, I believe. It's really nice. I've had it on my stream for years, and sometimes I think like, do we need new music? And then I'm like, no we don't. Our music is awesome. So yeah, let me see if it didn't mess with my microphone. It did mess with my microphone. Damn it. Let's see here. Now we're talking. Good. Yes. Okay, microphone levels are back to what they should be. Yeah, so we're in the pre-stream. We're going to hook up the thermal camera because I've been running a test, which is part of the secret, for a few days now, and I want to see the result of that before I turn it off. Right, so let's go to Wi-Fi, General Wi-Fi on, and let's turn RTSP on. Okay. Let's see what IP it got. It should get the same IP, but you never know. Let's see here. Alright, the music. There. Right, okay. So let's see. Thermo tools. Is it upside down day? Yes. No. No. Oh, there's an update. We always update during the stream because that is very smart. No, it's not, but we still do it. Let me adjust the ISO of this one too. There. Restart now. I always am scared when I push that button that it's going to restart my PC, but so far it's been okay. Okay. So now it installed the new version. Is it going to start up? I don't think so. Thermo tools. Okay, let's see. Video, connect. LAN IP is confirm. Of course it's not going to work. That would be too easy. Nope, it didn't work. 10, 24, 1. Yeah, that's correct. Okay, so we have to, I don't know, mess with the buttons a bit. Oh, so on is still off? How does that work? Oh, okay, it's laggy or something. Okay, let's try and connect some more. That's why we do this in the pre-stream, because we know it's going to fail. Anyway, what I wanted to do is I wanted to see... Oh, it worked. Hold on. Let me resize this, do a bit of this, and then we need this guy, and I need to see if this is correct. It is. Okay, and now I need to enlarge the font. Yes, good. Okay, now you guys can watch too. And this is a Dig-Quad version 4 prototype with a prototype ESP32 board, which has been running for 2-3 days doing effects and all kinds of other stuff. And before I turn it off and clean up my desk to look at another prototype, we're going to see how warm things got. So this is running at 24.5 volts. And we see that the input buck converter is 63 degrees. But that's after like a few days of, or I think 2 days of running, 24/7. And the inductor, how warm is the inductor? 50 degrees. Okay, that's all fine. It gets the hottest when running the highest voltage, right? So that's good. And then I want to see over here. Yeah, that's basically stone cold. Good. And we have the ESP here. Yeah, so the LAN chip is running a bit toasty because it's a LAN ESP32 sandwich, but it's well within specifications. This part should be fairly cold, while the PCB is warm, so that's okay. Okay, yeah. Yeah, all good. Can we see a fuse light up here? No, because we're not using a lot of power at all. This one is 33 degrees. Okay. Yeah, there's basically just one warm IC here. Maybe there's a little one over there. That's fine. Yeah, one warm IC, which is the expected one and well within specifications. Good. So we can now turn it off. Okay. Yeah, so this Dig-Quad, I guess we talk about the secrets whenever they happen during this stream. This Dig-Quad gets the same relay terminal from the Dig-Next 2, right? So you get this little included pigtail cable, which you hook up to your relay with a 5 volt ground and 5 volt trigger. And then you just boop, connect your relay like that. The end. No more messy wiring, no more double terminals, no more blah. Just like that. So easy, right? But we're not going to look at the Dig-Quad today. That's already, we looked at it in a previous stream, and there's only a few things that changed slightly. So that's not really anything new anymore. I'm hoping to get this out in a month or two, something like that, but we'll see. Okay. This is also a new LAN ESP32, so it has the ESP32 on there with 8 megabytes of flash and 2 megabytes of PSRAM for, future sustainability. Lots of stuff on there. And then we have the Ethernet all on the same board. And the production version will have a double stacked header, so it'll clear it nicely. Okay, so that tested great. So that's good. It's going to the lab on Tuesday. So that's going to be an interesting day. Let's hope we finally pass everything I wanted to pass. With enough margin. I already passed before, and the older versions did, but sadly the new changes didn't. Let me close the garage door because I was cooling the place off a little bit. I'll be right back. Before it turns into Bugzilla again, Bugville, we're going to close everything up again. There. Beam. I don't have a link for the double relay, and the double relay is also an issue because one of these, a single one, is fine, but using what? Why is it black? What did it lose connection? What? It did. Uh-oh. I also lost connection to my router. What's going on? Are we having technical difficulties? Can you even see me? So we had some dropped frames, but it's fine now. Let me reconnect the thermal camera if that's going to happen. Yes, okay, good. Okay, it did happen. Okay. I am unsure what failed in my home setup, but something might have rebooted. You updated the guide into your new firmware. I don't know. Anyway, the double relay, I recommend one of these, but two is going to draw too much power from the circuits I have on there. So that's going to cause a bit of voltage drop. So I don't actually recommend these, but I do use them to test. No, I'm actually dropping frames. I've dropped 25%. What? What is going on? Is my router overloaded? Hello, router. Add CPU. Add... No, my router's fine. Let me do a quick speed test here. Maybe the YouTube server's... Okay, my download is 900 something. So that's fine. Let's see, upload. Upload is... Oh, upload's way down. I'm at 400 upload. I should also be at 900. I'm not quite sure what's going on. What we can do is try and switch to the backup, the YouTube backup server. Wife on FaceTime. Again? Are we having networking issues? Or what's going on? Is it an internet issue? If it's an internet issue, it wouldn't explain the thermal camera cutting out. But I'm not seeing a rebooting access point or something like that, because that would show up in my router logs. Okay. I'm going to switch YouTube to the backup ingest server and see if that helps. But I don't think I can do that while streaming. No, I can't. Okay, the stream will be right back. Okay, am I back? That is the question. So I don't know. Are we back? Are we back? Are we in the same stream? I hope so. I think so. Can anybody, yes, back. Okay. So far, 0 dropped frames. Okay, good. Back. Check router from Magic Smoke. You looked very happy in the still. I think it's good. Yes. Okay, so I'm not seeing any dropped frames right now. So that's good. Never been away. Interesting. I don't know why my thermal camera would keep disconnecting, though. It didn't used to do that. Let's try and connect it again. Is this? Yeah, okay. Okay. So, thermal camera is back online. Can we see my hand? Yes. So my fingernail's really hot. Okay. Well, let's hope that fixed it. We're now on the backup YouTube ingest server, and so far, okay. Your arm hair is crystal clear. Oh yeah. Okay, so the real goal of today is this guy, which is also something I need to work on. And this, we'll talk about it in a minute. I need to deconstruct it. Because I've been running all kinds of tests. There, this just whoop, unplugs. Good. Okay, so this guy is the Dig-Next 4, or rather, it's the first prototype of the Dig-Next 4. And, well, you just saw it compared to a Dig Quad, and it's somewhat similar, but it has the Dig-Next DNA in there, basically. So we have two large input terminals, and the board will support up to 30 or 40 amps. I'm hoping I can make it do 40 amps. And it has the new ESP32 on there with 8 megabytes of flash and 2 megabytes of PSRAM. It has Ethernet. It has the relay socket. It has the QEXP socket we also got on the Dig-Next 2. It has an I2C socket. It has a whole new power system. It has the ESD and over voltage protected output stages for the data. And then I have to remove this little board. It has the Dig-Next 4 gets it has all the fuses, so it has 6 output channels for power, 4 times 4 amp and 2 times 10 amp. And in the future version, because I've already making changes to this guy, you could also replace the fuses with a 10 amp if you wanted to, but the total board rating doesn't change. So, dropping again. Yeah, I see it. Damn it. It happens when the thermal camera disconnects. Let me turn the thermal camera off. It makes no sense, but okay. Okay, let me reset the drops. I have no idea what's going on. Is my internet provider having issues? Yeah, because our upload... Let me check. Meldingen en storingen. Geen meldingen. Okay. Let me try a speed test again. Because my upload should really be, 900 something. So download. I could probably share this window. Browser. No, not working. Oh, now my download is okay. Ah, my upload is completely foobarred. Look at that. Yeah, go away. So I'm supposed to have 900 something down and 900 something up. But I'm getting 154 up. And clearly some packet loss now and then. What, is it doing something? No, the interwebs, my port on my MikroTik is called the interwebs. So let me check my PPP tunnel status. No, it's been fine. Uptime 12 days. Yeah, that's fine. Extended upload insurance. Yeah. Yeah, Foxionaire, the idea is that this is going to be... I'm going to continue and see if it drops again. In the Dig-Next lineup. So, as you know, the current... this is still attached to all kinds of stuff. The current Dig-Next comes in a very nice custom plastic case. And the idea would be that this board will also, again, come in a nice plastic case. But it has all the Dig-Next circuitry in there, basically. So, yeah, we have lots of fuses. We have up to 48 volt support, while the Dig Uno and Dig Quad stay at 24 volt. We have a capacitor per channel. This board, I'm working with 7.62 millimeter terminals for all the terminals. So we'll have 6 positives, 4 data, and 6 grounds. And yeah, one of the unique features I was testing on this board is I'm using a port expander to control the individual channels, because one of the features the Dig-Next has is that it can control each output channel individually in regards to power. And that is also what this video will, or this live stream will partly be about. Okay. Up until now, there was no way to control that. And I've been working with AI, my buddy Claude, to basically write a user mod for WLED so that we now have individual output channel control. On the Dig-Next 2, that's already working fine. But then also on a Dig-Next 4, or in the future, diff power, if you have like a board with 6 or 8 outputs, you can control all of those individually too, and they're automatically switched depending on if there's anything outputting at that moment or not. No, we're still good. We're still good. 0 dropped frames. And so this is using a port expander because I needed 6 extra GPIO pins, and with Ethernet on there, those just don't exist. And I wanted to use a different one. So the Power Manager Usermod now has support for different I2C expanders and something I call power sequencing. And we'll take a look at that today. One of the features the Dig-Next 4 will have is this little add-on board or riser board. Of course, it comes pre-installed and included. That is because I've basically removed all the LEDs from the board itself and put it on this little riser board. Now, this little riser board, the only function it has is the LEDs. So if you, for instance, have this controller and it has all kinds of lights on it and stuff like that, and you're like, it needs to go in a dark room, well, you can just go into the controller, pop this out, leave it out, and everything still works the same. You just don't get visual feedback anymore, right? But then it's a fully dark controller. So I thought that was a neat idea. And it also helps me in manufacturing because, well, this just slots in here like that. And I mean, as you can see on the board, there wasn't really room to add some more LEDs. I'm actually redesigning this part, so never mind that. But yeah, I think it's a neat solution in the end. Dig-Next isn't meant to be cheap per se, but like the best solution, right? And I think this is a better solution than having the LEDs on the board. You can still easily take it off and replace the fuses and things like that. But I think that is going to be excellent. I don't know where Johnny is. I saw that BitLooney was also streaming, so we sadly hit a parallel streaming moment. Otherwise, I'd be watching his stream. So that might be why some people are over there. So yeah, if you want pink status LEDs, you can switch this board. Sure, yeah. If you design your own version, I'll give you the pinout if you want. You can make pink LEDs, no problem whatsoever. Oh, that's actually a good idea there, Foxioneer. We could do the pink edition, but then not in the case, but having pink LEDs on here. That's a good idea. Okay, I'll keep that in mind. Anyway, for today, we're going to be running some tests, and especially I want to show the multi-relay feature while we're using this prototype, basically, right? As I said, there's already massive changes planned for this prototype, so don't, get stuck on anything you see here right now, because they're very likely to change. Addressable RGBs, yeah, they make them that small, but that's kind of going overboard there. Would be a lot more expensive too. Without much added function, I think, but yeah. Let's hook it up by Ethernet. And, oh god, I need more room on my desk. This is going over here. So let's set my power supply to 5 volt. Because otherwise things are going to fry. And I'm going to hook up 4 LED bars to the LED outputs. So we can look at the individual features. Okay, first I'm going to boot it and reset the configuration to default. Let me do that, 5 volts, yeah. As you can see here, the LEDs and stuff like that. Let's see. Security, factory reset, save. See if that works. In theory. No, they have them in 1 by 1 millimeter, I believe. Oh god, did it lose Ethernet too? No, it did not. Okay. Let me fix something real quick. This is still very much a prototype, so I need to fix some stuff. Let's see, reboot. Yes, that's correct. Okay, good. Then we can hook up the LED bars, and then I can show you how the power manager works. So let's see here. Let's get the LED bars. We made these many years ago already. And these are just bars with 144 SK6812 RGBW LEDs on there. And let's hook them up to the board and see if all the outputs work. Yeah. They do. So I need to, because in the actual production version, the terminals will be color coded, so that will make hooking up things a lot easier. In this version, they are not. 1, 2, 3, 4, 5, 6. Oh, 6. I'm just gonna do them in the same order. Actually, I should do it the other way around. 1, 2, 3, 4, 5, 6. And I mean, in the end version, this will also be in a case, right? And then there will be lettering there and stuff like that. Okay, 1, 2, 3, 4, 5, 6, 1. Maybe we can speed this up a little bit. No. Yeah. Okay, so that's LED bar 1. Let's look up the rest. We're going to need 4. Now it's a bit easier to see where everything goes. Oh, there's a different bit on here. Hmm? Okay. Hold on. Do I have... Where did this bit go? Oh, it's over here. Good. Whatever. Let's see if this is a bit quicker. It is. I'm actually going to skip this one. So this is a prototype for a Dig-Next 4. And there's already many changes planned, but I've made software which exposes a feature of the Dig-Next series which wasn't exposed up until now. And we're going to be using this prototype so we can test it a little bit and then also show off that software. Let's see here, this one. No, there is no Dig-Next 3. They're named by the amount of data channels they have. Okay. Let's see. Let's put this over here. Let's put it somewhat closer together. Okay, so I guess we don't need a thermal camera right now because it keeps failing anyway. Yes. Actually, yeah. Martin, in the pinout guide, the pins that are used have always been there. Let me check. Oh, right. Browser. There. So Dig-Next 2, pinout guide, and we can see that on the Dig-Next 2, GPIO 20, 21, and 22 control the various internal relays. They're MOSFETs, but sure. And then GPIO 5 controls the external one, right? And for the Dig-Next 4, this hasn't been published yet because this is in no way finalized. So, okay. So let's turn that on. 5 volt, good. Don't want to blow them up all at the same time. Okay, we get some light. That's good. And let's get the browser in here and make it a bit transparent. There, that's actually perfect. Okay, let's get a little relay board. I'm just going to hot plug it. There. Okay. Oh, can't see that. Yeah, good. So by default, still, even with this modification installed, everything works like you'd expect, except it doesn't. Oh, there he goes. Okay. So this has 4 data outputs and 6 power outputs. And it has some updated power circuitry, but that doesn't really matter for functionality. Yeah, mostly just more. Oh, and it has Ethernet. And yes, it'll be in a nice custom plastic molded case again. It'll be higher. It'll be double, right? So double the ports, double the power. Ah, good luck, Greg, with the press. Oh, you got stuck having... Okay. So anyway, out of the box, everything still works as you'd expect. Let's configure the LED bars real quick. I don't need a brightness limiter. I want SK6812 and I have 144. SK6812, 144. SK6812, 144. And we have the make a segment for each output turned on, right? Because we have 4 data channels and we want each data channel to be its own segment. Oh, look at that. We've got orange. Okay, so let's run an effect real quick. Just something simple. Blends. Yeah, that's not visible on camera at all. Aurora. I think I need to turn down my top light. There, now we can see something. Let's see, blends. Still too bright, huh? Okay, I need to adjust this camera a bit. Okay, now we can see somewhat of an effect. That's cool. Okay. No, it's not replacing the Dig Quad. It's Dig-Next is a separate lineup. Dig Quad is also getting an update. I actually showed that slightly earlier in the stream. But that's been delayed, sadly, for a few months now. I'm hoping to get that finally fixed next week. But yeah. Okay, so right now everything works as a standard WLED board. We have an AC relay which can turn on and off the AC power supply, and then we have 6 output channels, and those just if we turn off the power, those just all turn off at the same time. And okay, the relay's already time delayed, but sure, but I don't mind that. And we can turn it on again, and everything turns on, all good. What I've done is in here. So we go to Usermod. Oh my god, this is invisible. Okay. Okay, let's try it like that. We go to Usermod and then we scroll down. We now have a new user mod that's called Power Manager. And Power Manager is heavily based on the multi-relay user mod that actually shipped also with the Dig-Next 2. It was made by Blazon-Sec many years ago, and it's been great, but I've been missing a few features. So first we have it enabled, because it's a user mod, so you can enable and disable it. And then we have a first segment that says take over all relays. That basically means that if a relay isn't configured, it'll be off until it's configured. And I'll show you what I mean by configured in a minute. So let's do that real quick. Take over all relays. Save. You see that all the relays now turned off. That is because we haven't linked the relays yet. And what I mean with that is we have our 4 segments, And wouldn't it be cool, because we connected all the power to a dedicated output and the data to a dedicated output, if we could switch a dedicated output with the power. And there's now a new menu here called Power Relays, and we can say, okay, segment 0 is linked to 5A1. You can see it turned on, the LED bar is now on, and, well, that's basically it. So we can turn it off again, and we can turn it on again. Yeah, and we can go to segment 1 and say, okay, our power relay is 5A2. Good. And we can go to segment 3. Our power relay is 5A3. Good. And the last one is 5A4. Good. Now, another thing you already saw there is that here it actually knows the names of the output, just like they're named on the Dig-Next 2, for instance, and as they will be on the Dig-Next 4. If we look here in our user mod for the power manager, we're going to skip all of this real quick. We see that we can now enter a name per relay so that we can see on the board what is the actual relay linked with the output, right? So I can pre-flash this so you don't have to fill that in yourself. That is automatically configured. And we can go back and we can see all this information over here. Or we can go to the info screen and we can see Power Manager has 7 relays. It's using this port expander. We actually talked about it last week. It found one, and relay 0 is the AC relay. That's this guy. And it's automatically following any segment. So the AC relay is now automatic in that it'll turn on when if there's any segment still having power, and if there's no segments that have power, it'll turn off the power supply automatically. So you don't have to use the big power button anymore and things like that. That is all arranged automatically. So if we, for instance, turn off all these segments, so this segment off, you can see the LED and the bar turning off. So the bar turning off was already a thing, of course, but now you can see this LED turning off. That means that channel no longer has any power coming out of the board. Okay, so we can turn this one off, we can turn this one off, and we can turn this one off, and then we can wait a few seconds. And then it automatically turns off the AC relay. And if I turn on a segment, it turns on the AC relay, and then the power comes back. Now, why is there a delay there? That's a good question. And that is because if we look at the power manager, and then the master AC relay, that is this functionality basically, we can select which port that's on. In this case, that's this port. We have a delayed off of 5 seconds. So that means that even when all segments are off, the AC relay waits for 5 seconds before it also turns off. You could set this to 1 minute or 5 minutes or something like that. And that is to prevent that the AC relay, which has the big power supply connected, turns on and off too quickly, right? If you're messing with a lot of segments, or someone turns on the light in a room, someone else turns on the light in a room, and they turn off and they turn on and they turn off, turn on. You don't want to switch the AC relay each time for that. So you can add in a delay time that it stays on until everything is off, just to try and have it switch a bit less. And then there is another setting called Stabilize S. And Stabilize S is if you switch an AC power supply, it doesn't instantly start giving power. Before, WLED didn't really take that into account. It said, okay, your relay is on, and we're doing fades, and we're doing all kinds of crap. But you never saw that. It just instantly came on, or it flickered, or something weird happened, because WLED wouldn't wait for the AC power supply to actually turn on. So in this case, we can set a value. I called it PSU stabilization. After master AC relays power on, if I turn power off, all the segments are off, but the relay is on. Now it clicked off. Well, no, okay, now everything is off. If I then hit power again, it turns on, waits a little bit, and then it turns on the segment. So this basically enables independent power management per segment, which, you know, didn't exist before this week. And if we start renaming relays, it'll actually start to make more sense. Hallway, I don't know. Let's say you have various lights spread out through your home. Right? I don't know. No, I don't think this will be part of... Oh, there was a delay. Oh, right. We dropped 1,000 frames again. No clue. I don't think it'll be merged in main WLED at some point. So it'll remain a user mod, but I've published the user mod on the Intermit.Tech GitHub. So basically anyone can use it. It's not limited to QuinLED, except that no other board than the QuinLED boards have the hardware to do this. So yeah. And the Dig-Next 2 already has all this hardware. As I said, there just wasn't any software up until now. So what more does it do? Well, if we turn everything off and turn everything on again, you can see that there's still some delay. Right? Hold on. There's still a little bit of delay. And the reason for that is, next to power sequencing, I also wanted to get rid of all the annoying flashes that happen sometimes when you turn on and off the power. No, this is the one. Fonctionnaire, this is the one I submitted the PR for. Oh, when I did something in... Oh, right, I see it. I don't know, man. I think that's just coincidence. But we lost another 500 frames. No idea. And it's network lag. I mean... My router isn't saying anything. Anyway, one more thing that it tries to do is to prevent bright flashes when the LEDs turn on and off, and especially when power turns on and off. So there is a new mechanism that'll send black frames, basically black LEDs, to each segment you're turning on and off, 200 milliseconds before and after it powers on. And the idea is that the LEDs will be in a known state before they actually receive power. And once they receive power, you know, they know to stay off until they get the correct LED data signal. So that already prevents a bit of flashing. There's stuff in the circuit. There's a bleeder resistor and things like that in the circuit to also make sure that power is bled off, you know, correctly. And then there's a min-off time, which means to give this bleeder a bit of time to actually draw down the power. It makes sure you wait when turning on and off a port. If you, for instance, set this to 0, let's see. Your AC power supply. So you generally have a big LED power supply. If you want to do all power saving possible, you'll have a relay on the AC side, and then you'll have the board powered by that power supply, which then turns off and off and on and off. Okay, when we need to disable the other measures too. So let's make this 0 and 0. and a 0. We're basically disabling all the measures I put in place to prevent flashing. So let's see. And now it's of course never going to flash. Oh, there. You saw it spasm a bit. Let me turn this off. Turn this up a bit. Oh, saw the flash? Yeah. There, saw that flash? It's a bit hard to see still. Let me do this more. Okay. No, we're good this time. Still. There. Flashed again. No, worked. There, flashed again. So, to prevent those kinds of flashes, especially if you have this connected all around your house, and it's dark at night and you want it to slowly fade up to a low level, the whole internet's going down, yeah. Oh wow, yeah, we're seeing a lot of drops. Does it drop while I do that? That's impossible. Yeah, I don't know. I think my provider is having issues. Let me try another speed test. So, down is fine-ish, I guess. Oh, it doesn't do upload? Upload 0. What? Oh, okay, it's still working. Yeah, this upload's okay. Interesting. Yeah. Let me try a speed test again. It's fluctuating a lot, but... Hey there, Ghibli. Oh, now the upload's fine. No idea. Yeah, now we're also not getting any dropped frames, so... No idea. Anyway, I was showing that without these measures in place, if you turn it on and off a few times, there we go. You'll generally see a flash or something like that happen before the LEDs turn on. And if these are the lights running your house, well, that's kind of non-desirable. So that's why I put some extra options in here. We can do the pre and post blanking, so 200 milliseconds before and 200 milliseconds after it'll send black frames. So let's see if that's already enough. It depends on the LED type and the IC type and things like that. So now when I turn it off and I turn it on, you'll see well, it's 200 milliseconds, so it's really not a long delay. Yeah, put it in there. Okay. But you can see that the LEDs now turn on slightly before the bars turn on. Let's see if we can still make it flash. Nope, so far so good. Oh, this wasn't covered yet, Ghibli, but this one has an onboard microphone, and the Dig-Next 2 also has an onboard microphone. But the Dig Uno and Dig Quad and Dig Octa version 4s, which will come out as soon as I can, but probably a month or 1.5, those will also all have onboard microphones. So you can see by doing the pre and post frames, we haven't gotten it to flash once. Let's see if I can do it faster. Not so much. Nope. Okay, let's leave it off longer. Nope. Yeah, so basically this is my attempt at trying to fix the flashes you can get, especially on some controllers, when turning on and off the power, right? And I basically set out to fix that. And, well, so far, I think it did that. Oh, can you disconnect the mic? No, there's no method for that built in, but I just deconfigure it. So just not put the I/O pins in there, and then yeah. Yeah, one is more for the DIY crowd, and the other is more if they want a fancy box and things like that, and the latest circuits. It's also more expensive, so I mean, yeah. Which fade are we talking? This is linked to the WLED fade. So if I say 2 seconds over here, for instance, and I now hit the power button, it'll fade out much slower and fade in much slower. Deconfigure. Yeah. I'm going to defill this drink. Yeah, so you can still change the effect or the time here and things like that. That functionality hasn't changed. Fairy dust. What does that do? Oh, okay. If it's 0, will it flash? I don't think so. Let's see. That's a good question, Soul Juice. So off, on, nope, off, on, nope, off, on, nope, nope, nope. Seems to work well. Let's give it some more power. Whoa. Off, on, off, on, off, on, off. Okay, so since we've added this blank pre and post pre, we haven't seen a single flash. Sure, exactly, Greg. That's why I try and make it. Let's put these back to 0 and see if we do get a flash then. I don't know. Okay, off, on, off, on, off, on, off. Not yet. Let me put the brightness a bit lower. There was some errors. Yep, errors. Okay. Oh, I saw a flash. We got a flash. Yes, basically everything will get a built-in microphone, Ghibli. So Dig Uno, Dig Quad, and Dig Octa, and all the ESP variants. Oh, flash. So that's the issue. I can't reproduce when it flashes. The problem is that it does. Yeah, if you want 50 units, contact me on Discord and we'll work something out. I have to remind you, these aren't available yet, but they will be in, I hope, a month and a half or so. But yeah. Flash. Okay, so let's put my my pre and post blank back. I also want my stabilized power supply. There. Okay. Well, I can test it another 100 times. I know this works. Yeah, okay. Right, so that is the idea. It adds... so Power Manager versus Multi-Relay adds a I2C expander I want to use. It's basically a different IC. It adds the master AC relay functionality so that it's automated. You don't have to hit a button anymore. It adds that you can add that you can name relays, that you can link relays to a segment so you can have it turn on and off per segment, and it can do various power sequencing instead, including pre and post blanking frames to make sure your LEDs don't flash when starting up. But you can do even more advanced stuff. Let's say the power supply you're using, it isn't that great. Now, let's say this relay can turn on immediately. This relay has a delay of 1 second. This delay is 2 seconds, and this one has a delay of 3 seconds. Okay. So now if we turn everything off with the main power switch, everything turns off. We'll wait for the AC relay to turn off. Okay. And then if we turn it on, it'll turn the AC relay on, wait, and then turn it on in sequence. Haha. So if you have a massive LED install connected, but your power supply browns out when you turn everything on at the same time, you know, we have 6 outputs here. If you have like 12 gauge in each of them with 600 5-volt LED, I don't know, whatever. I can understand that if you turn them all on at the same time, power could sag. So now we can what? All right. We can make them turn on somewhat delayed. Right? And we can also change a delayed power off if, for instance, you had a group, or let's say LED 1, relay 1, 5A1, someone, you know, it's one that turns on and off rapidly, right? And then you might not want it to immediately turn off the relay if it gets turned on like 50 times an hour or something like that. So if we add 10 seconds of delay off time to the relay, yeah, hit me up on Discord, Ghibli, and we'll talk. If I now do this, it doesn't turn off until we wait 10 seconds. And now it turns off. So I can turn this on and off, rapidly. That's all fine. It still does the pre-blanking and things like that. Or it doesn't need to do the pre-blanking because it doesn't turn off, sorry. So we can do this like all day long. And then once I actually leave it alone for 10 seconds, it actually turns off. In this testing setup, I am using SK6812 144 LEDs a meter, and these bars are 1 meter long. Right, so we could actually no, I don't have the power meter connected, but we could draw some power here. Okay, I want some fading. No, 0. Let's go white. Whoa, and then add white. Whoa. Okay, we're currently drawing 18 amps or 93 watts. Let's tone that down a little bit. It's getting warm. No, this is just a standard relay you can buy from AliExpress or Amazon or something like that. It's a 5-volt relay board, and then you'll find dozens. So I don't offer those myself. And the pigtail, so this pigtail to the relay board, that is included with the Dig-Next 2. Yeah, so that's why I built these boards with the insane 144 SK6812, because I can draw about 20 amps or so with 4 bars, right? So each bar can draw about 5 amps. And we can see that, except that the LED status board is there. Let's turn that off. For this board? No, this board is a prototype, so it's not really rated for the current. But it is an interesting test, and one I wanted to do today is because... let me turn it off. Because this board is 1 OZ copper on the outside, and then it has 4 internal layers, so it's a 6-layer board with 0.5 OZ. And I did want to test how warm they get with 5 amps. So let me try and connect the thermal camera again. And then we can have some fun. So let's go. Let's see if the internet will start hiccuping again. Wi-Fi on. RTSP on also, I don't know. Let's see. Thermo tools, connect. Failed to connect. Of course it did. I don't know. We'll go back. I never know what makes it work. Failed to connect. Okay. Nope. Failed to connect. Okay, I have to push more buttons. I don't know why. Let's push this button. Failed to connect. Connect. push this guy. Ah, and there it is. No idea. Zero clue what happens. There. Okay. So now we have our thermal camera. Let's see if anything is still lingering. No, everything is nice and cool. Okay, let's turn on the power. We should be able to see a little bit. Okay, so this is the Ethernet IC. You know, that always gets a little bit warm. That's fine. ESP is over here. Here's our inductor and a load switch and a DC converter. There's one here too. Let me enable an option here. There. Okay, so the LED bars are on. No, the stream is working as far as I can see. Let's output some more power. So now we can see that some of the fuses are lighting up. These are all 5 amp fuses, so we're going to be pushing those. We're currently at 15 amps. Let's add the white channel also. Oh, now we're at 25 amps. So we're actually overloading these fuses. Let me turn that down a little bit. Hold on. Let's turn this option off again. There. So let's load them up to 20 amps. Sorry, I don't have the power supply connected right now. Okay, we're at 20 amps. So each bar, in theory, is now doing about 5 amps. So final boards will have 6 layers of 1 OZ, not just 2. But you can see the fuse here on the left, and then you can see the MOSFET there on the right. Those share a copper plane, so that's why they're heating up at the same time. But I mean, the MOSFET is 44 degrees, and that's just heat that's bleeding off of the fuse, really. Because we're running a 5 amp fuse at 5 amps. Generally, that wouldn't happen, except when you have this very high density LED strip. Normally, voltage drop would prevent that. Yeah? All good? I haven't had any dropped frames for a while now, Ghibli. Not sure. That's actually performing better than I would expect it. But as you can see, if we would add the 10 amp fuses to the mix also, there's a lot of heat to dissipate. So the production version will have 6 layers of 1 OZ. And why will the final version have so many more layers versus the prototype? No, it'll have the same amount of layers, but more copper per layer. And yeah, less copper is cheaper. Especially if I don't make it like 500 or 1,000. For prototypes, it adds up a lot of costs. For the final boards, it's a lot less. It's like a difference of $1 a board if I use the more copper or not. And then I'd rather use it because everything, well, has more copper to spread the heat and then dissipate the heat, right? We can see the board starting to heat up. So now you can also see the over here, right? This is also starting to get warm. Still, this is already 20 amps going through the board. Oh, I didn't enable... Wow, those bars are getting hot. There. I didn't enable the center one. Or the software didn't. Sure, this is... yeah, so we're kind of overloading these fuses. Normally, they wouldn't see more than 4 amps. The power consumption with everything is off. Less than a watt. Yeah, but you're not supposed to run a 5 amp fuse at 5 amp. Can we see the wires here? Oh, that's okay. You can see the wires over here. These are 18 gauge silicone wires, so that's perfectly fine. Let's see the input wire. Whoa, input wires are getting hot. That's because we only have a single wire connected. But that should be good for like 20 amps. Sure, 46, 47, that's okay. Our relay is hot. Our relay is warm. Anyway, should we try and blow some fuses? Let me up the power even more. Okay, I need to up the limit on my power supply. There. We're now at 25 amps. That's the max these can do. Wow, they're getting hot. So we're now overloading each of the 5 amp fuses, but we're only overloading them a little bit. That is the hardest case to deal with. It's easier if you overload them a lot. Still, the board is handling the heat okay. Ah, hot. My eyes are burning. Have to hydrate. Are we already over 100 C? No. Maybe over here? 99.9. Oh, there we go, 100. Problem is they need like 125, 150 to pop. So it's not enough load to make them pop quickly. The light channels, sure. So I just have it on RGB white and then dedicated white and then at 100% on solid. Oh, we can see if we can turn it off and turn it on again. Or a power sequence is still working. It's not really visible, huh? So let's do that again. Off. And you can see the bars turn on individually. The lights in the channel's temp. What? Oh. they're pretty beefy aluminium channels. So that's why I can do this. It's like big hunks of metal with lots of surface. Okay. Yeah, these aren't actually LED profiles. They're just some random metal bar. But they work really well. Another advantage of having DC power turn off is I can work on the channels without turning the board off. Let's put 2 in a single channel. Okay. Now that will pop a fuse. So let's turn this off. Turn this off. Okay, let's turn them on. Okay, let's there. Which fuse is it? Let's give it a bit more. I think it's this one. Let's go. And it's dead. Yep, okay. Oh, that's actually a good test. Let's turn everything off. Where's my... Let's see if the broken fuse indicator works. It does. As soon as the channel turned on, we can see that the fuse is broken. So the circuit works differently as on the Dig-Next 2. So here you can see the relays on and the fuse is broken. On the Dig-Next 2, it will just show a broken fuse then and not the relay on. But it's a different circuit I'm working with. I don't think that's a problem because you can still clearly see which channel is broken. So then you can replace that fuse. It's a bit dim though. I need to make it brighter. Okay, well, that is the Dig-Next 4 prototype. Lots of changes are going to happen. I'm already working on those. So, and the Power Manager Usermod. I just noticed I forgot to put anything in the description, so let me add that. The WLED Usermod Power Manager. Let me turn this off real quick. Stream settings, edit. Save. There. Currently we don't have any, since this is very new and I'm testing it still, we don't have any firmwares available for the Dig-Next 2 with it included, but that should change coming week. And I think I talked about all the options. Yeah. Do you guys have any questions about that? I guess the name Power Manager is pretty self-explanatory now. If you work with port extenders, you may include a broken fuse indicator in WLED. Oh, you mean a software feature where you can see if a fuse is broken? Wow, that would involve a lot more circuitry. It's on the top board, so I'd have to transport it back down again, and I'd need like eight more pins. I'll have to look into that. And then maybe, like currently we have the info over here. Oh, I didn't save the segment names. Oh well. So this also works if you rename a segment and name it kitchen. If you then look in the info screen, you can see it also names it kitchen, right? Yeah, I'm just thinking about how that would work. Would you want like a pop-up, like a fuse is broken, or? Let me check why my phone is dinging the whole time. Yeah, fixed it. Yeah, okay. I can look into that. Maybe. I'll give it a maybe. Problem is it adds extra circuitry, complexity, and thus also cost. And always have to weigh the features versus how many people will use it, but how many people have to pay for it then, right? So I'll think about it. Let's see what I can do.
Well, here goes nothing.
Well, the good thing is this port expander is a 16 port version. So I have plenty of ports available on it. No, this is just the calculated power usage. The problem is if you make a board that does 40 amps and you want to measure power measuring up till like 5 or maybe 10 amps is fine. But if you want to do 40 amps, it's going to add a lot of heat. Uh-oh. We were... are you back again? Reconnection successful, says OBS Studio. Things are not going well.
Just listen.
Yeah, I think we're back. I don't know what's up today with the stream, man. Your can LED modules? Maybe. What is going on? No. Wait. So my connection to my router just dropped. So is it the PC or is it like one of my switches? Let me check one switch. This one. 12 days. Okay. Uh-oh. No, okay. It dropped once. That's fine. It's also not it, huh? I was just checking my 10 gigabit switch, but that's saying everything is fine. No clue. Reset my router? Yeah, maybe after the stream. But it almost has to be an internal problem if I'm losing connection to my router. How odd. Or maybe it's this darn switch. Which switch am I plugged into? Let me check. Okay, I'm plugged into that switch. Let's change switch. So this goes away. Wire mess, hold on. In theory, there's another Ethernet connection here. In practice, it's a mess. Is it this one? I think so. Hold on. Getting cable out of mess. Oh, you can do it? Okay. There. Okay, we're blinking again. Can we refresh the page? Refresh. Yes, okay. I changed the Ethernet connection to a different switch I have here, which is not the uplink switch. No clue. Although I think we're going to be done with the stream pretty soon, but yeah. Yeah. Power relay. Or yeah, power manager, sorry. Would also have been a good name, power relay. Yeah, so for the Dig-Next 2, this already works, and I said we'll have binaries soon. The Dig-Next 4, of course, will have this and others in the Dig-Next lineup, because that one of the features of Dig-Next is having the per port controllability. But also for diff power, this is going to be very interesting because it enables you to turn on and off the remote boards locally, especially once the larger controllers come out, which will have like 6 or 8 ports on them. That will be a very nice feature to have. Due to the software update, maybe. Oh, the processor affinity. No, it's set by the executable name, so I think it's fine. Yeah, I have no idea. Weird. Okay. Yeah, and well, short stream, I guess, today. If there's not any more questions, how long have we been going? 1 hour and 22 minutes. That's not a lot. Yeah, that's what I think too, Functionaire. And especially if you're using this for like home stuff, being able to turn on and off individual outputs is going to be very nice. And not having the irritating flashes. I need you to focus on making a version for cars automotive use. I've never delved into that. Maybe at some point once all the currently planned updates and releases are done. Maybe I'll look into doing some automotive stuff, but not right now. I wonder what will happen with the broken fuse light. I think it'll turn off when I turn off the relay. Yeah, okay. Works. Nice. power management is the big problem. You mean in automotive use? Well, it depends what we're talking about. My boards, except the Dig-to-Go, aren't designed to be the most power efficient for running on a battery or something like that. But they don't use an excessive amount of power either. I mean, yeah. I mean, we can show it actually. So if we take, let's see, this guy. Oh, don't do that. Okay, and yeah, the problem is this cord is only just long enough. There, you can see my USB connection here. If I now plug in USB to the board, the onboard electronics will be powered using the USB. Now we have the relay connected. That's going to draw a bit of extra power. So let's disconnect that. There. So as you can see, currently the board is fully powered from just this USB connection. The LEDs are being powered by the main connection, but yeah, the board is running all its onboard electronics and standby and conversions and things like that from, so I can turn off this power also. It doesn't make a difference because that's coming from the main power supply. I can turn the main power supply off. Okay, main power supply is off now. Yeah, we're still getting 5 volt and 3.3 volt for the main and the USB, but the 3.3 volt, oh, these LEDs are wrong. Oh, okay, I need to fix the LEDs. Or the labeling, because the main is still on, but the main is off. But the 3v3 is now off, which is still on. Let me make a note. No, okay, it's okay. I'll remember. Anyway, this is the actual current draw of the electronics on the board, right? I can turn the power on again. Oh no, I can't turn the power on again because there's no power. There. Now there's an issue in this prototype where I probably can't turn it on anymore. Nope. I have to reboot it. That will be fixed. Yeah, I remember. No worries. Okay. So yeah, the dual power feature is still there. You can run all onboard electronics, including Ethernet and relay control and things like that, from the USB-C socket. And then you can turn on and off the AC power supply to save even more power there, because large AC power supplies can often idle at like 6 or 7 watts, while the board only needs like a watt. So, yeah. Okay. Yeah. Well, a bit of a different stream than the last few streams where we worked on PCB design. We'll probably pick that up again next week or the week after. I'm not sure yet. But I wanted to test this board and do various things with it. Some good things popped up. And I'll improve the prototypes. But this is like in 4 to 6 months time product, right? So don't expect this to come out next week or something like that. As I said, I'm already redesigning a lot of the circuits on here because I want to do them differently. And then we'll make another prototype. And, oof, sorry. We got to test those, and yeah. 1 watt is very little. Yeah, 1 watt is not a lot. Yeah. Sure, Ghibli, if I ever make an automotive board, that would be a good thing to include. Yes. Okay. As I said, short stream today. Thank you all for being here and testing with me, and I'll be back in the future with other stuff or the same. Thanks, guys. Bye-bye.